Friction can be a very powerful force. And in engineering, we often think of friction as just this source of inefficiency or source of something to overcome. But there's a really interesting example of using friction to help in the design and construction process. And specifically, it's about the Burj Khalifa, the world's tallest building. And so, kind of backing up a step before we talk about it specifically, if we think about supporting a building, often what will happen is you use pilings or something, go down to solid bedrock, you put pilings, then you build up from there. That's how Manhattan is built. And part of that's because the bedrock is really so close to the surface in Manhattan, and all the skyscrapers in New York City are built on that bedrock, so not very far to dig down, and then a very solid base. The Burj Khalifa, where it's built in Dubai, has lots of sand and sandstone, and so there's nothing really to drill down to get that solid bedrock to build up from. And so what is used in the Burj Khalifa is actually friction to hold it in place, to hold that building in place. Almost 200 pilings are used there, but instead of going down to something solid, what they use is the friction force between the pilings and the sand or sandstones that are under the ground there. And so the friction between around all the surfaces of all the pilings is used to stabilize that building. Another thing that's really helpful on the Burj Khalifa is the shape of the building. So it's not a perfect square. If you've seen a picture of it, it's not rectangular or square, no sharp edges. And those wind forces are reduced because they don't have the 90-degree angle. So there's a lot of interesting developments and techniques and technologies that are used in the Burj Khalifa. Right now I'm focusing on friction itself and the friction that's between the pilings and the sand that's around it to help secure and stabilize that building. In a lot of ways it works kind of like a hairbrush. If you think about all the pilings that are the hairbrush bristles, and then all the weight is going to be supported above it. Those pilings are surrounded by the sand and using the friction to hold it in place and secure that height of the world's tallest building. So really very, very impressive structure when you think about the technology that went into place there. One of the classic engineering slip versus tip problems deals with friction. And so the concept is, if you have some object, depending on where you apply a force, may determine whether the object is likely to tip or whether it will slip along that plane. And what's really important is the friction between whatever your object is and the surface it's sitting on. That friction force resists that movement. And so if we have a very smooth surface, likely wherever we push, we're going to have this object slip instead of tip. We inherently think about this. If you've ever moved furniture around a room or a large box, you may recognize that if you push at the top, the whole box may tip. I had to put my finger here to keep it from doing that, because with this smooth surface, even as high as we push, it's just going to slip across this surface. Low down it obviously will, higher up it will as well. If we have more friction between the surface and our object, and I've used a rubber placemat here, if we push low down, we still may get that slipping phenomenon, but if we push up high, we're likely to get tipping, because it's going to create a moment around this point and it's going to tip if we push high. So pushing here, we'll get that tipping. And all that has to do with, the only difference is the friction between the material that our object is resting on. Instead of it being smooth like this table, we have something that creates a lot more friction between the surface of our object and that friction force. So friction can be very, very, very important, and can also be useful and helpful in the design if we're using it in a way that a design incorporates the strength of that friction force. Another interesting example, if we think about paper, and we may not think of paper as having a lot of friction, but this shows how powerful it is. This is just two books that are pages are interlaced, maybe about 150 pages each, and there's no extra pressure pushing down on this, but just pulling this apart is impossible for me. And all that's in there is just the friction between each page and the page that's on either side of it. And pulling this apart is very difficult. So that friction force is very, very strong, and we can use it for good in the example of the Burj Khalifa not being able to go down to solid bedrock, but actually using the friction between the sand and each piling is what helps keep that building secure and stable.